Welcome to Functions Part 2. In this video, we're going to look at how the functions that we learned about in Part 1 shift and how to find the equation if the function has shifted. This video is for grade 11s and 12s only. Alright, so let's start with the parabola. In question 1, we're given a diagram of a parabola and we are expected to find the equation of this parabola. Okay, we obviously know that a standard parabola will have a turning point at 0. It will have the turning point at x0 and y0 at the origin. But this particular parabola has a turning point at that coordinate point. So it has shifted. Alright, so how has it shifted? It has shifted twice along the x-axis. So it has shifted by -2 along the x-axis. And it has shifted 4 times up. Okay, by 4 units up. So it has shifted by 4 units up. So by -2, 2 units to the left, and it has shifted 4 units up. Okay, so the general formula that we use when we have a shifted parabola is A equals to x minus p, alright, and square your bracket, plus q. The p is the shift along the x-axis and q is the shift along the y-axis. So let's put those shifts into our formula. So along the x-axis, the graph shifted to the left by -2. And along the y-axis, the graph shifted up by 4 units. Okay, let's simplify. Alright, now what's left is for us to find the value of A. Alright, so how do we find the value of A? We could choose any coordinate point as long as it's on the graph. We could choose any point as long as it's on the graph, and I think that would probably be the easiest point to choose there. Over there, we could choose this point over here. And what are the values at that coordinate point? The values at that coordinate point, of course, x is -1 and y is 3 at this point. Okay, x is -1 and y is 3. So let's substitute that point into our formula. Y is 3 and x is -1. Okay, so we've got 3, -1 plus 2 is just 1. Of course, 1 squared is 1, and of course, a times 1 will be a. So if we simplify, we'll find that the value of a is 3 minus 4, which is -1. And once we've found the value of a, now we may write our equation. So that a is -1, x plus 2, bracket is squared, plus 4. So that is the equation of the shifted parabola. Alright, now let's move on to the hyperbola. Alright, this is what we know. If a hyperbola is standard, in other words, it hasn't shifted, then it will have asymptotes at x equals to 0, y equals to 0. So what does that mean? That means it may not be equal to 0 and it may not be equal to, x may not equal 0 and y may also not equal 0. So there are asymptotes there. But this hyperbola has shifted, so it will have new asymptotes. And how do we find those asymptotes? Very easy. For x, so the asymptotes of a shifted parabola, for x, we'll just take the denominator part of the fraction, so x plus 2, and equate that to 0. And if we solve that, we'll find that this function will have asymptote, the x asymptote at x equals to -2. All right, so we could draw an asymptote. We draw a dotted line at x equals to -2. And the y asymptote is easy. The y asymptote is basically the vertical shift. In this case, the vertical shift is just 1. So that means the y asymptote will be 1. Okay, so the y asymptote, we just get it from the constant, the vertical shift. So it's 1. So we put another dotted line again at 1. Okay, so we've got our asymptotes there. Asymptote at x equals to -2 for x, and the y asymptote is at 1. So once we've plotted the dotted lines of our asymptotes, remember now, our graph may not touch these asymptotes. We can now substitute different points in order to find at least 2 coordinates. So if we take our graph, our function, and where there's an x, we'll just put brackets there, and then we're going to try out different values. Ideally, we want to try out 2 values to the left of the asymptote. We know that the asymptote is at -2, and we also want to try out 2 values to the right of the asymptote, starting with -6. Let's try out -6. If we try out -6, we get -1/2, which is basically -0,5. If we try out -3, we get -5. Now let's go to the right hand side of the asymptote. If we try out 1, put 1 into our equation, we get 3. Finally, we try out 0. We try out 0, we get 4. Okay, so let's draw a dotted point at those coordinates. So we've got -6, x is -6, and y is -1/2. That would be that point there. X is -6, and -1/2 would be a point over there. Okay. So -6 and -1/2 would be a point over there. Just in between. Let's try to get that right. So just in between 0 and -1. So it's that point over there. -3 and -5 is this point over here. And to the right, we've got, try those points again, -6.5, -3 and -5. Okay, -3 and -5. So we could basically draw a line, a curve rather, through those points. And we just have to ensure that our curve does not touch our asymptote. So let's try again. Drawing a curve through those points, and it may not touch our asymptotes. And we do the same thing on the right. We've got 1 and 3. 1 and 3 is over there. 0 and 4. 0 and 4 is over there. Again, we draw a curve to those points, and we make sure that our curve does not touch our asymptotes. That would be the graph for that particular function. Okay, let's move on to finding the inverse. Okay, we've got a hyperbola function again, and this time we do not have to sketch the graph, we just have to find the inverse. So what is the inverse? The inverse means that x becomes y and y becomes x. So to find the inverse, where there's y we'll put x, and where there's x we put y. And then we must solve this equation in terms of y. Alright, okay, so how to start? We could take the positive 1 on the other side of the equation, it becomes negative 1. Okay, we swap those two values. So y plus 2 comes to the right, and x negative 1 becomes the denominator. And if we're solving this in terms of y, we can take the positive 2 to the right hand side of the equation, and that would be our inverse function. Moving on now to an exponential function. We are asked to shift this exponential function by 1 unit to the left and 2 units up. And of course, if we are shifting this function, remember this is the function, it's given there. We want to shift this function by 1 unit to the left. It'll become positive 1 along, the graph will become positive 1. And if we're shifting by 2 units up, it becomes positive 2. Okay, remember we always write the inverse operation into our graph, inverse to the shift, because when we solve this x plus 1, if we solve it, it will be x equals to negative 1, which obviously indicates a shift of negative 1. So because we're shifting to the left, it's negative 1, but when we plug it into the equation, it will be the inverse of negative, which is positive. I hope that makes sense. All right, so what we want to do now that we've got the new equation, all right, we could then substitute different values so that we could sketch our graph. Okay, we've got 2 to the power of x, of course we use brackets where there's x, plus 1 plus 2. So let's try out different values starting with negative 2. Negative 2 will give us 2.5. If we try out negative 1, let's try out negative 1. If x is negative 1, then y is 3. Let's try out 0. If x is 0, y is 4. Finally, we'll try out 1. If x is 1, then y is 6. Alright, so what we want to do now is we want to plot those points. Okay, the important thing to also remember before we plot the points is that the exponential function has an asymptote at y equals to 0, so it may not touch y equals to 0. Now, because the graph is shifted up by 2 units, the asymptote will no longer be at 0, but it will now be at 2. So for the exponential function, we've got an asymptote again at 2. So let's draw a dotted line at 2. Y equals to 2 because the graph is shifted up by 2 units. All right, and now once we have drawn the new asymptote, we may substitute our different values. Okay, we've got a coordinate at x equals to negative 2 and y equals to 2.5. So negative 2 and 2.5 is over here. Okay, negative 1 and 3, negative 1 and 3 is over there. And again, it's 0 and 4. 0 and 4 is over here. 1 and 6. 1 and 6 is over there. We can then use our points to draw. So we draw a curve through those points to find the shifted exponential graph. Okay, and remember also this exponential graph may not touch the asymptotes. Okay, we move on now to the last question, question 4. In question 4, we're looking at reflections. The graph has been reflected. You're asked to reflect this graph in the x-axis and also in the y-axis, which is very, very, very simple. Remember, a reflection means if we're talking about your reflection, you look at yourself in the mirror, you're still the same, you're just reflected on the other side. So if you're reflecting a function in the x-axis, x will stay the same, but y will become negative. And if you're reflecting your graph in the y-axis, y will stay the same, and the x will become negative. I'll repeat. A reflection in the x-axis means the x stays the same and y becomes negative, and a reflection in the y-axis means that y stays the same and the x becomes negative. So if we're looking at our function, if y stays the same, you see the y has stayed the same and the x has become negative, this will be a reflection in the y-axis. Okay, because x is still the same, but y is still the same, but x is negative. And this function will be a reflection in the x-axis. As you can see, that's x. X hasn't changed, so this is a reflection in the x-axis because x has not changed, but y has become negative. I hope that makes sense to everyone. Thank you. Remember to like and subscribe this video. Till next time.